before we begin, I would like to acknowledge a few people who've made tonight's talk possible. Particularly, I'd like to acknowledge Craig Martin from the Botany Department, who's been instrumental in working with me and making the arrangements for this lecture, and the financial and logistical support for Dr. Lovelock's visit here at KU has been provided by the Environmental Studies Program, the Hall Fund for the Humanities, Student Union Activities, Environs, and Student Senate. I'd also like to remind you that there is a reception following tonight's talk that will be in the Big 8 room, and you'll have the opportunity of talking directly with Dr. Lovelock if you have any questions or issues that you want to take up with him about tonight's talk. Dr. James Lovelock, tonight's speaker, has very broad training. He has degrees in chemistry, medicine, biophysics. He's worked at the Common Cold Research Unit. I still don't quite know how you study the common cold, but maybe at some later date he'll tell me. He worked at the National Institute in the United Kingdom. He was a Rockefeller Traveling Fellow at Harvard and Yale. And from 1961 to 1964, he was a professor of chemistry at Baylor University in Houston. And it was during this stint at Baylor that he began to work on the development of the Gaia Hypothesis. It is this theory which has pushed us to think in ever-expanding ways and scales about the life and the organization of our planet. His work has been recognized with numerous honorary degrees and international prizes, including being made a CBE by the Queen of England in 1990. He's not an environmentalist. He's not a conservative. He's not a radical. He's a scientist. He's pushed us to critically think about the world we live in. Please join me in welcoming Dr. James Lovelock.
Thank you, Dr. Hamburg, for that very generous introduction. I'm pleased and proud to be here in Kansas and most grateful to you all for inviting me. And both my wife and I are deeply impressed by the wonderful climate you have. We can't wait until tomorrow to see what new surprise you have for us. The German writer Hans Jost once said, "Whenever I hear the word culture, I release the safety catch of my Browning." Now, I don't know what in particular incensed Hans Jost about culture, but I suspect that he knew that the word usually prefaced a gush of hypocrisy. For me, the same kind of anger comes when I hear that cliché, the fragile earth. I get ready for a flood of words and a televisual presentation of cuddly animals and lush vegetation. The words usually come from some prominent green presenter, but to me, they sound green only with the mildew of insincerity. In Victorian times, that same word fragile was used with a similar tendency to describe women and to justify their domination. They were called fragile because it implied a kind of feeble delicacy that needed male protection. Well, as you know, Victorian women were not fragile. They were tough. They had to be to survive. And so it is with the Earth. Fortunately for us, it's very tough indeed. In the near 4 billion years of its existence as a live planet, it has survived at least 30 major planetesimal impacts, each of them devastating enough to destroy more than half of the life that was present. In addition, the output of heat from the sun has increased by 25%, and perturbations have occurred, such as the sudden appearance of oxygen as the dominant chemical gas. What we are now doing in the way of pollution and destruction of natural ecosystems is, by comparison, a most minor upset. Those who call the Earth fragile, or who say that some human act will destroy all life on Earth, are either ignorant of what the Earth really is, or are using the term Earth metaphorically as a synonym for people. Either way, we use fragile as did those Victorian men about their women, applying to our planet a dependent status, almost as if it were a possession. We still talk about the Earth as if the planet in our minds were one of those multicolored spheres marked in the colors of the political territories of the tribes and nations of the land masses of the Earth. The real Earth, that stunning blue and white sphere, has become just a kind of visual cliché, no longer an inspiration, but a banal image advertising soap on satellite television. I want to talk to you this evening about our relationship with the Earth. And in particular, I would like to put before you some thoughts on the consequences of taking on the responsibility for the management, or if you prefer it, the stewardship of the Earth. As the only organized intelligence, perhaps we have the duty as well as the right to take charge of the Earth and to govern it responsibly. Maybe so, but first we must ask, what is the Earth? This may seem a trivial question. Everyone knows what the Earth is, but unfortunately there seems to be no common view, almost as if the Earth were an evolutionary inheritance which we, like fleas on the back of a camel, just take for granted and never seem to notice what it is. Even scientists differ about what the Earth is. There are three main scientific views of our planet. Firstly, there's a small minority, which includes me, who call ourselves geophysiologists, who see the Earth as a quasi-living system, or if you prefer it, a planetary-sized ecosystem, something I like to call Gaia. We postulate that this system automatically regulates such important properties as climate and atmospheric composition, so that they are always more or less comfortable for living organisms. A larger minority prefer what the climatologist Stephen Schneider has called coevolution. They see life and its environment as only loosely coupled. They agree with geophysiologists that the composition of the air, the ocean, and the rocks is affected by the presence of life, but they reject the idea that the Earth may be self-regulating so as to sustain a comfortable environment. Coevolutionists recognize the need for interdisciplinary research and are the force behind the global change and the international geosphere-biosphere programs. It may be some time before we know whether coevolution or Gaia is nearer the truth. There are a few, mostly geographers, who see the Earth as a whole, but the majority of scientists, even if they give lip service either to Gaia or coevolution, still act as if the Earth were a ball of white-hot, partially melted rock with just a cool crust moistened by the oceans. On the surface, they see a thin green scum of life whose organisms have simply adapted to the material conditions of our planet. And with such a view go metaphors like the spaceship Earth, as if humans were the crew and the passengers of a rocky ship forever traveling an inner circle around the sun, as if the 4 billion years life has existed on Earth were just to serve as our life support system when we happened to come aboard. Seen this way, obviously, the Earth might appear fragile, like one of those great greenhouses called biospheres in Arizona. Those who so see it must wonder how it survived so long. Well, this is the conventional wisdom about the Earth, and it's the wisdom that is still taught in most schools and universities. It is almost certainly wrong and has arisen as an accidental consequence of the fragmentation of the sciences, a fragmentation into a growing collection of independent scientific specialties. Practicing scientists are, of course, aware of the limitations of this diffuse conventional wisdom about the Earth, but even when they are specialists in some branch of the earth sciences, they still seem to act as if the diffuse wisdom were true. If we as scientists, for example, want to know something about life, the universe, or the Earth, we read about it in the Scientific American or the New Scientist. But back in the lab, where serious science is done, we continue in our own specialty without concern for either the general wisdom or the intricate details of the specialties of our close colleagues. If you think I exaggerate, I advise that you try attending discussion meetings on 3 closely related Earth sciences. For example, on one day you could choose to attend a discussion on the chemistry of stratospheric ozone, and on another day a discussion on the geophysics of fluid motion in the oceans, and on the third day a discussion of the geochemistry of rock weathering. These are all Earth science topics, but you would find little that was shared in common between them. More seriously, a large proportion of the scientists attending each of these meetings would be unaware of the researches of the others. Of course, no single scientific approach can lead to a complete understanding of the Earth. All are needed. We need the reductionist model of the Earth to understand details at the molecular level, and a key example of this is the chemistry of the stratosphere. And it was only the application of classical atmospheric chemistry and physics that enabled Rowlands and Molina to first make known the threat to ozone from the chlorofluorocarbons. Then from biogeochemistry, there came, through the work of G.E. Hutchinson, the recognition of the role of microorganisms in the soil and the oceans as a source of methane and nitrous oxide. And from geophysiology came the recognition that atmospheric gases like carbon dioxide, methane, dimethyl sulfide may all be part of a physiological climate regulation. We're at a time when scientists as professionals seem to have lost sight of the Earth as a planet in the intricacies of detail. As a result, when confronted with environmental concerns, they tend to think about specific dangers to people, especially themselves, and ignore hazards that loom on a planetary scale. The foremost personal and public fear is that of cancer. Consequently, any environmental chemical or radiation thought to cause cancer is given attention out of all proportion to the real risk it poses. Nuclear power, ozone depletion, and chemicals like dioxin and PCBs are regarded as the most serious environmental hazards because of this fear. But also, I think, because both nuclear radiation and halocarbons are so easy to measure with the instruments we have available. I think that the potential hazards of the gaseous greenhouse and of land abuse have until recently been ignored because they perturb the planet, not individual people, and because they are very much more difficult to quantify. Magnificent numerical models of the atmosphere are used to advance the science of weather forecasting and to predict the climatic effects of greenhouse gas accumulation. The scientists who play these models would be the first to admit that they are far from able to include the full effects of clouds in them, and they would confirm that they're still less able to include the effects of the internal climate of the oceans, and almost entirely unable to take aboard the changing and responding ecosystems at the surface of the Earth. So how are we to know what the Earth is as a system? How can we govern it if science is still decades away from telling us what it really is? Should we wait for the deliberations of the plenary session of the All Science Interdisciplinary Congress? Or should we listen to thoughtful environmentalists like Jonathan Porritt, who often ask, can we afford to wait for scientific certainty before taking action on environmental affairs? Consider, for example, the accumulation of the chlorofluorocarbons in the atmosphere. No one doubts that the CFCs have reached a level that is already damaging. We are all agreed that the emissions of the long-lived chlorofluorocarbons should be banned immediately, and legislation is already in place to do this. So sensible environmentalists of the Green Movement are puzzled about why, if this is so, we continue to spend billions of scarce funds, science funds, on stratospheric and ozone depletion research, when the problem is in effect solved. We know the poison, all we need do is to stop imbibing it. If we were serious, say these environmentalists, we should be considering, in addition to a worldwide ban on the manufacture of long-lived CFCs, the general problem of their uses. How can we refrigerate and air condition without letting loose these kind of compounds to the atmosphere? How can we dispose of the last stocks of CFCs in storage and in the refrigerators now in use? Compared with the excitement and the glamour of research in the upper atmosphere, or of the exquisite physical chemistry experiments, or of elegant computer models, the disposal is a problem for mere engineers, the rude mechanicals of science. Proof of the lack of this kind of simple engineering research is the fact that a substantial proportion of all of the CFCs still entering the atmosphere comes from leaking car air conditioners. Surely an engineering problem that could easily be solved. The Greens are, I think, right. Engineering research urgently needs doing and should be at the top of our list of priorities for action rather than at the bottom. We don't need to burn 1 billion candles to specialist scientific research. It only pollutes the air and in the end may do nothing but confirm that it is too late to postpone our doom. So let's spend our cash now with a planet, not people in mind. Otherwise, we are like a farmer who would mortgage his land to pay for his children's education, not realizing that in so doing he was denying them their inheritance. In the last century, Victorians were faced with environmental problems just as serious as those that face us today. In the mid-19th century, there were epidemics of waterborne diseases like cholera and typhoid that caused the death of 1/3 of the inhabitants of a city within months. Science was not then organized as a powerful lobby and was prepared to admit that it did not know the cause of these diseases. Physicians at the sharp end of this battle suspected from the epidemiology of the diseases that infection was waterborne and came from the bad odors of the primitive sewerage systems then in use. Our sensible forefathers did not pour funds into the infant science of microbiology and wait until it proved that cholera and typhoid were waterborne bacterial infections. They acted promptly and empirically by installing clean water supplies and efficient sewage collection and disposal plants. Engineering was in those days a proud profession and triumphantly displayed its self-confidence in those amazing Gothic pumping stations, now a place of pilgrimage for students of architecture, and of course succeeded in eliminating the waterborne diseases long before their cause was discovered. But one should also remember that the present green movement itself is a potent force preventing environmental reform. It has anachronistic views of industry, which it regards as harmful and polluting. The movement includes many who condemn and dislike both science and technology. Some green philosophers and leaders are refugees from the older humanist movements. Among them are those primitives who see all industry as inherently bad and existing solely to benefit profiteers. Others are like William Morris groupies who would return to a romantic but impractical rural existence. Now, this kind of green nonsense is encouraged by the tendency of talented writers and dramatists to cast their villains as the owners or employees of the nuclear and chemical industries. They go on to make these industries the stage equivalent of desecrated graveyards in Victorian melodramas. The nuclear industry is all too often seen as a place of quintessential evil. The flood of green propaganda ignores that few of us could survive if we gave up our industrial civilization. But more seriously, these storytellers deny us the possibility that industry could reform and become non-polluting and benign. And as always, their concern is for people, not for the planet. We could go along with the more responsible among the Greens and still retain the long-term guidance of science if we could first delineate the near certainties and then act empirically in an engineering way. We now know, for example, from the record of the gases trapped in the layers of Antarctic ice, just how the atmosphere changed in the past 200,000 years and how the climate changed too. We know for certain that the carbon dioxide 15,000 years ago in the depths of the Ice Age was about 180 parts per million, and that at all times there has been a close correlation between carbon dioxide and temperature. The rise in temperature and rise in carbon dioxide over a period of only a few hundred years, close to 12,000 years ago, was 3 degrees and 100 parts per million respectively. In the past 200 years, we have increased atmospheric carbon dioxide by 80 parts per million, and if we take the greenhouse effect of chlorofluorocarbons into account, we have already effectively increased the greenhouse effect by as much as happened between the Ice Age and the interglacial that followed. So we are near certain that the mean global temperature will rise, even if we stopped all emissions now. The uncertainty is less about how much it will rise than about how fast the rise will take place. So if we emulate our Victorian ancestors and develop an empirical approach to planetary problems, we might find it helpful, even if notionally, to introduce a new profession, that of planetary medicine. It would stand to specialist earth science in the same way that medicine stands to biochemistry and microbiology, and would be the environmental equivalent of the practice of medicine. Its general practitioners would be concerned about the health of the planet, and an important part of their practice would be planetary preventative medicine. For example, let's consider the production of electricity. Fossil fuel burning power stations are among the principal atmospheric sources of carbon dioxide, sulfur, and nitrogen oxides. They are at best only 40% efficient and waste the rest of the energy of the fuel in those ugly cooling towers that advertise their presence. Attempts to remove sulfur oxides from the effluents of these power stations so as to reduce acid rain at distant places would be seen by a planetary physician as treating a symptom only. There is no reason why coal should not be burnt so that most of the energy is made usefully available, and that the pollutant emissions are gathered and either used profitably or stored where they will do no harm. I have been told by several of the large oil companies that pilot plants in which coal is converted to hydrogen and carbon dioxide already exist. In these plants, hydrogen would be the fuel of gas turbine power stations, and the carbon dioxide collected and disposed of underground or in the oceans. At present, although less efficient in energy terms, these alternative power stations are not yet competitive with conventional power stations. No sensible engineer would expect pilot plants to compare in efficiency with the evolutionary product of a long run of commercial operation. Also, the cost of pollution is not yet charged against the power producers, and a change in attitude could make these non-polluting ways of burning fossil fuel, in fact, less expensive than the conventional power stations we use now. It will not be easy to convert industry to supply and distribute alternate fuels like methanol or hydrogen for transport, but obviously in so doing, the emissions from road vehicles and aircraft could be greatly reduced, even eliminated. Another way for the broader vision of a planetary physician's approach would be through the re-examination of that 20-year-old photograph of the Earth taken from space. You know, the one that showed our planet as a beautiful and seemly thing when seen in its entirety. This picture of the Earth would remind us that 70% of the surface is ocean, something we often forget in our concern for the affairs of humans on the land surfaces. We're just beginning to glimpse the extent to which the world's oceans and marine life in them are important in regulating the climate and the chemistry of the Earth. The algal life of the oceans is important for climate in three possible ways. Firstly, by the emission of sulfur gases that oxidize to form the cloud condensation nuclei. And the clouds over the oceans may therefore be a consequence, a direct consequence, of the organisms that live in the sea surface. It may be some time before the importance of this observation for global climate is established, but clouds do seem to have a net cooling effect. And my colleague Andrew Watson has drawn my attention to the fact that the long-term average of cloud distribution seen from space shows that the clouds do congregate over those areas of the ocean rich in algal growth and not elsewhere. The second discovery concerning marine algae came from the observations made by a number of my colleagues last winter in the North Atlantic Ocean. They found that the great springtime blooms of the diatoms that cover areas of millions of square kilometers use up the carbon dioxide in the sea surface so much that its concentration falls to a level far below the equilibrium with the atmosphere. They serve, therefore, as a powerful pump that removes carbon dioxide from the air. Prior to this discovery, geophysicists were confident that the transfer of carbon dioxide from the air to the ocean was simply a matter of physical solution. And this is not so surprising, since measurements of gas transfer made by geophysicists between the air and ocean were mostly made by graduate students during summer cruises when algal blooms were not present. The third way in which algae can affect ocean climate is simply by their presence or absence. In the absence of algae, or if they grow as large organisms like the seaweed one finds in the Sargasso Sea, the ocean water is so clear that sunlight penetrates deep and doesn't heat the surface layers. Conversely, the dense growth of microorganisms in the sea surface absorbs and scatters sunlight and causes surface warming. Satellite photographs of the ocean show large clear areas north and south of the equator and an increasing algal density in the northern and southern oceans. And I suspect it will not be long before this is linked to some form of climate regulation. The re-examination of the Earth by a planetary physician would reveal also that the forests of the humid tropics are another region of the Earth's surface with a significant climatic role, and one under threat from people. In spite of optimistic signs coming from Brazil and Colombia, we're still removing tropical forests at a ruthless pace. Yet in the First World, scientists try to justify the preservation of the tropical forests on the feeble grounds that they are the home for rare species of plants and animals, or of plants that contain drugs that could cure cancer. They may well do this, but they offer so much more than this. By their capacity to evaporate vast volumes of water vapor, those forests serve to keep their region cool and moist by wearing a sunshade of white reflecting clouds and by bringing the rain that sustains the trees. Their replacement by crude cattle farming could precipitate a disaster for the billions of poor in the Third World. Sir Crispin Tickell, who was until recently the United Kingdom's representative to the UN Security Council, movingly portrayed in a recent article the human suffering, the guilt, and the political consequences of a refugee problem involving a major part of the humid tropics, something that is certainly one of the greater threats ahead. The change in land surface when the forests went would also, of course, have secondary climatic consequences for us here in the temperate regions. That this is a real danger was illustrated in an unusual television documentary about the Panama Canal shown a few years ago. The documentary was about the history of that amazing feat of engineering, and it was used to illustrate a new threat to its continued function. The threat was not, as you might think, from local politics, but from agriculture. The canal climbs over the Isthmus of Panama through a series of locks, and the entire system is powered and kept filled with water by the abundant rainfall of that humid region. But the rain and the trees of the forest are part of a single system. And now that the forests are being removed to make cattle ranches, the rain is declining, and it's thought may become too little to sustain and power the canal. I hope that somehow, if this happens, the fact that this great work of man, of engineering, is threatened by our insatiable desire for beef, might bring home to people the consequences of deforestation. As a planetary physician would see, the great forests of the tropics are part of the skin of the Earth, and like human skin, they sweat to keep us cool. The tropics are warm, humid, and rainy, an ideal environment for trees, but few seem aware that the trees themselves keep it this way. The wet and cloudy tropics are not a given state of the Earth. It is an environment maintained by the ceaseless evaporation of water through the leaves of the trees. The rising water vapor condenses to form the rain clouds that persist above the forests. And if the trees are felled, the rain ceases and the region turns to scrub or even desert. Trees and rain go together as a single system. Without one, you cannot have the other. Sweating is part of our own personal refrigeration system, and the evaporation of water from the forests is part of the cooling system of the Earth. It works because the white clouds that persist above the tropics have a net cooling effect. Maybe you think the forests are so vast that it will take decades to clear them significantly. If you do, you could be wrong. Until recently, an area of forest equal to that of Britain was raised annually. And at this rate, in 10 years, 65% of all of the tropical forests will have gone. And when more than 70% of an ecosystem goes, the remainder may be unable to sustain the environment necessary for its survival. To denude the earth of forest is like burning the skin of a human. And as you well know, burns of more than 70% of skin area cannot be survived. Brazilian scientists were once asked by their government to calculate the value of their forests in the Amazon as producers of oxygen from the world. The government spokesman argued that without the oxygen the trees produced, fuels like coal and oil would be worthless. Some charge should therefore be made for the export of this essential gas, oxygen. Now, it was a nice idea, but unfortunately calculations of the net production of oxygen by the forest gave an answer close to zero. You see, the animals and the microorganisms of the jungle use up almost all of the oxygen the trees produce. Amazonia may not be worth much as a source of oxygen, or by the same calculation as a sink for carbon dioxide, but it is a magnificent air conditioner, not only for itself, but for the world, through its ability to offset, to some extent, the consequences of greenhouse gas accumulation. Do these forests have an estimable value as natural, regional, if not global, air conditioners? One way to value the forests as an air conditioner will be to assess the annual energy cost of achieving the same amount of cooling by mechanical means. If the clouds made by the forests reduce the heat flux of sunlight received within their canopies by only 1%, which is, I think, an underestimate, then their cooling effect would require a refrigerator with a cooling power of 14 kilowatts per acre. The energy needed, assuming complete efficiency and no capital outlay, would cost annually about $4,000 an acre. So how does this compare with the benefit of the land cleared for cattle raising, which is its usual fate in the humid tropics? Well, an acre of cleared tropical forest is said to yield meat for about 750 beef burgers annually. Meat worth at the site of production not more than about $20, and this only during the very few years that the land can support livestock. Unlike cleared land in the temperate regions, beef production cannot be sustained in the tropics, and the land soon degenerates to scrub or even desert. So next time you eat a burger, or better still, watch someone else eating it, think of the real cost of its production, the stripping of an asset worth about $80. Yes, the 55 square feet of land needed to produce enough meat for one burger has lost the world a refrigeration service worth about $80. And on this basis, an accurate but imprecise estimate of the worth of the refrigeration system that is the whole of Amazonia is about $200 trillion. Such a valuation, in terms of the refrigeration capacity of the trees alone, must be an underestimate, for they also serve an immense irrigation function. And just now the forests sustain also a home, a habitat for vast numbers of organisms, including 1 billion people around the earth. The forests are more valuable to all of us than we have yet grasped. They are like love itself, something so valuable that we take it for granted. Common sense now tells us that in the absence of a clear understanding of the consequences of what we're doing to the earth, we should cut back our pollutions and land abuse to the point at least where there was no annual increase. But like all acts of self-denial, it's all too easy to put it off until something happens. Well, I can't arrange or predict anything exciting enough to make us give up polluting. But what I can do is to tell you a fable about an environmental problem that afflicted an imaginary industrial civilization that existed 15,000 years ago. Just about the time that our immediate ancestors appeared on the Earth, 2.5 million years ago, the planet itself was changing from a state where the climate was comparatively constant to one where the climate cycled periodically between glacial and interglacial phases. The ice ages were long. They lasted about 90,000 years. And in the intensely cold winters, ice extended to within 45 degrees of the equator, down to St. Louis, in fact. The warm periods, the interglacials, were brief, lasting only about 12,000 years, and climate then was like the one we now enjoy, or at least did enjoy, until quite recently. I would like you to imagine that civilization became industrial 15,000 years earlier than in fact it did. And this requires an increase of only 0.5% in the rate of evolution of human society, not a very big change. I would ask you to envisage a civilization very like ours, but existing 15,000 years ago, just as developed, just as polluting, and with meetings like this one to discuss the consequences of it in progress. The main difference would be that the Earth was then in the cold state of an ice age. The climate here in the position of Lawrence would presumably be somewhat like the climate of Alaska, and there might have been few inhabitants. The ocean would be more than 400 feet lower than it is now, and a vast area of land, mostly near the equator, that is now under ocean would be dry land and populated. Let's imagine that the civilization developed and became industrial somewhere in the region that is now Japan and China. The cold winters, with the need for housing and heating, stimulated invention. And the region, of course, was also rich in coal, oil, and mineral deposits. And soon these were exploited, and there followed a rapid progression through water and wind power to steam powered electricity and then nuclear power, just as we've seen take place in the last 200 years. Greenhouse gases, carbon dioxide, and methane from extensive agriculture began to rise, and before long, the climate in the tropical regions became perceptibly warmer. A large part of the civilized world was then in those tropical zones, and these were becoming uncomfortably warm for their inhabitants. The nations of the north were efficient at producing consumer goods. They were like the Victorian British or the present-day Japanese. And needs, of course, always drive invention. So soon, refrigerators using chlorofluorocarbons were pouring from production lines and were shipped to customers worldwide. It was not long before scientists began to realize that the global environment was changing. A few of them stumbled on the fact that the CFC gases leaking from refrigerators were accumulating in the air without any apparent means for their removal. And soon it was discovered that the CFCs were a threat to the ozone layer, and that if their growth in abundance in the air continued, the ozone from the stratosphere would be so depleted that many, especially the fair-skinned, would be in grave danger from the ultraviolet component of sunlight and would develop skin cancers. There was an explosion of hype in the media over this threat, and funds flowed for science as never before. Governments were reluctant to act because the CFCs were known to be harmless in the home and were the most efficient refrigerant gases that could be used. And they were also the basis of a large and profitable industry. They were reluctant also because there was no evidence of any increase of solar ultraviolet at ground level. Indeed, there was evidence of a decrease, so nothing was done to stop the CFCs rising in abundance at about 10% each year. A few scientists felt frustrated because they knew that the real threat from the CFCs was not ozone depletion, but their property of blocking the escape of outgoing heat radiation from the planet. CFCs are, in fact, more than 10,000 times as potent greenhouse gases as is carbon dioxide. But the fear of cancer always seems to transcend other dangers, and as a consequence, ozone depletion was the issue that received most attention. Greenhouse warmth was known about, but was regarded as a good thing since the world was so cold anyway. Nobody then knew that in 2,000 years' time, the planet was destined to make one of its characteristic jumps in temperature to an interglacial. The polar regions in the Ice Age were so inhospitable that there was none of the clear, strong data from ice cores that we now have to help us understand the past. The jump in temperature due in 2,000 years ahead would come because the position of the Earth with respect to the Sun was changing in a way that increased the heat received from the Sun. It was a small change in solar heating and by itself insufficient to precipitate the interglacial. But at the time near the end of a glacial period, the Earth is in a state highly sensitive to small perturbations. A minority opinion among the scientists held that the increasing warmth from greenhouse gas pollution would start to melt the ice caps, and that the flooding of low-lying tropical forest land would then take place. And this in turn would release vast volumes of methane gas as the vegetation rotted beneath a few feet of seawater. The methane would cause more greenhouse warming, and soon, by a runaway positive feedback, the planet would heat and melt the vast polar caps. They warned that the rise in sea level would ultimately be 450 feet, enough to drown most of the large towns and cities of the then civilized world. But then, in those days, as now, most centers of civilization were, of course, right at or close to sea level. Now, this pronouncement was treated with derision and contumely. Ozone depletion and the dangers from nuclear power were the main interests to both government and environmentalists alike. Soon the CFCs reached 5 parts per billion in the air, and ozone holes appeared over both of the poles. Now, by themselves, the ozone holes were of no consequence, since nothing lived anywhere near the Ice Age polar regions. But their presence was enough to tip the balance in favor of legislation to ban the CFCs. Unfortunately, it was too late, for the greenhouse balance had also tipped, and the planet was now like a boat passing over the edge of a waterfall, moving ever faster towards the heat of an interglacial. The polar ice was already melting, and within a few hundred years, all of that Atlantean civilization was deep under the ocean. The legend of a flood and of a great empire beneath the seas persisted, and stories about it were reiterated over the campfires of wandering tribes of hunters. If there is any moral to be had from this tale, it is that we are very lucky to have chosen to pollute the air when the planet is at its least sensitive to perturbation by greenhouse gases. But if we look at the Earth as I do, as a superorganism, then we need to make sure that some other surprise may not be waiting to do to us some other unexpected damage, a surprise that might even be as great as that which confronted those imaginary Atlanteans. So let me conclude with some further thoughts about this dangerous illusion that we could be stewards of the spaceship Earth. Everyone these days is or aims to be a manager, and this may be why we talk about managing the whole planet. Could we, by some act of common will, change our natures and become proper managers, gentle gardeners, stewards, taking care of all of the natural life of our planet? Could we do this? Well, I think that we are full of hubris even to ask such a question, or to think of our job description as stewards of the Earth. Originally, a steward was the keeper of the pigsty where the pigs lived. Well, this was too lowly for most humans, and gentility raised the sty ward, as he was called, so that he became a bureaucrat in charge of men as well as pigs. Do we really want to be the bureaucrats of the Earth? Do we want the full responsibility for its care and health? I would sooner expect a goat to succeed as a gardener as expect humans to become the stewards of the Earth. But much worse than this, there can be no worse fate for people than to be conscripted for such a hopeless task, to be made accountable for the smooth running of the climate, the composition of the oceans, the air and the soil, something that, until we began to dismantle creation, was the free gift of Gaia. I would suggest that our real role as stewards on the Earth is more like that of the proud trades union functionary, the shop steward. We are not managers or masters of the Earth. We are just shop stewards, workers chosen because of our intelligence as representatives for the others, the rest of life on the planet. Our union represents the bacteria, the fungi, and the slime molds, as well as the nouveau riche fish, birds, and animals, and the landed establishment of noble trees and their lesser plants. Indeed, all living things are members of our union, and they are angry at the diabolical liberties taken with their planet and their lives by people. People should be living in union with the other members, not exploiting them and their habitats. And when I see the misery we inflict upon them and upon ourselves, I have to speak out as a shop steward. And I have to warn my fellow humans that they must learn to live with the Earth in partnership. Otherwise, the rest of creation will, as part of Gaia, unconsciously move the Earth itself to a new state, one where humans may no longer be welcome. Thank you.
Dr. Lovelock would be willing to entertain a few questions from the audience. Silence. You've awed them.
There's one.
My understanding that in another 4 billion years or so, the sun will start to turn into a red giant, and all the life on the planet will just fade. And where does that fact fit into your conception of life on Earth?
Well, it fits in very well. I think the fact that the sun will eventually swell up to become a red giant is almost certainly true. It seems to fit very well with almost all astronomical models of stars. But a thing we don't commonly realize is that it has been warming up ever since it began, and the process is exponential. And the 25% rise in heat output since life began on the Earth is the first part of it. And as time goes by, that process goes on inexorably. We don't have to wait until it's swelled up to be a red giant. It may be too hot for us in perhaps 2 billion years.
What do you think would be the sustainable human population of the planet in the long term? Is 5 billion too much now? Are we close to the point where we're going to be at the sustainable point?
That's an almost impossible question to answer. It's not just the number of people, it's what they're doing. For example, if now we got rid entirely of farming by keeping cattle, we could very comfortably sustain our present population and probably one double or even quadruple the present one.
So, well, let's say with the economy like the United States, obviously this country uses a lot of the resources of the world. So at this kind of economic level, how many people do you think would be?
I wouldn't like to guess. It would depend entirely on what people could be persuaded to do.
If I'm to believe this flyer, your views are considered anti-Darwinian. Do you consider that to be the case?
No way. No way whatsoever. I regard Darwin as a very great scientist, and nothing he has said in any way is contradictory to Gaia. I'm afraid that a number of opponents of Gaia try to put out the notion that it's anti-Darwinian, but it most definitely is not.
You've said that human beings could alter the Earth to a point where, or the system would alter itself to where human beings could not exist, but maybe life could not be totally eradicated. Do you believe there is any way that human beings could, say, through some sort of global nuclear war, somehow upset the system, go past the threshold to a point where life could not exist?
I find it very hard to believe that we could do anything like that. I think it's part of our hubris to imagine that we could destroy the system. You have to remember that events like planetesimal impacts are incredibly devastating. Some of them are thought to have destroyed as much as 75% of all of the organisms on the planet, and yet the system recovered. It had a fever for a while afterwards, but it recovered.
You said that you're not an environmentalist, and yet you also said that if we change our nature so that we are not so that we are stewards, that we are in control, but that we limit our destructive behavior, that we can live kind of in harmony with the world. How does that seems to me simply to be a different aspect of environmentalism. I was wondering if you could comment how the two are different. Why environmentalism is not the label that you choose to do.
I picked that. I'll take claim for calling
Yeah.
it not an environmentalist.
Maybe,
Yes. They're not a usual environmentalist.
In the coastal areas, there's a lot of loss of knowledge by the indigenous people. It's been discovered that a lot of the materials that they use hold a lot of promise for pharmaceuticals. Could you address not only the loss of cultural heritage, but the loss of future potential in the tropics?
As an old-time chemist, I am not very easily persuaded that there exist in tropical regions plants that have drugs that are going to be unique. Chemistry has reached a point where the synthesis of biological materials is particularly easy, and coupled with our knowledge of genetic engineering, I cannot see that the chemist can't mimic anything that is being done by plants under rare conditions. Also, I think much more important than that is the fact, as I tried to stress, the value of those forests is as an ecosystem that is keeping the region and the earth cool. And if we stress the importance of cancer-curing chemicals and things, businessmen and governments are going to say, well, so what, that's not all that important, and just carry on with the cutting of them down. Whereas we might persuade them that if they're removing a really valuable resource, that they shouldn't be doing it, but they should be costing it somehow.
If you had the power to affect one major political change right now to change all this for the better, what would you do?
Put an enormous tax on cattle.
Costa Rica is one of the countries that has most suffered from removing its tropical rainforest. And a couple of years ago, my students were studying the cause of the removal of tropical rainforest there. And we were very surprised to find that most of the rainforest being removed in Costa Rica was not indeed for grazing of cattle, but merely to keep down the possibility that poachers would come in to the privately owned forest land and then have to be reimbursed for their, quote, improvement of the land. So to avoid this pseudo-improvement, the owners of the land cut down the forest just in order that they might retain ownership for no productive reasons, even including the cattle. Do you have any response to that?
No, I'm interested to hear of that. I'm sure there are many variations. Cattle farming is not the only, by any means. I mean, the harvesting of wood is obviously, especially hardwoods, is also one of the causes. But I think, on the whole, cattle farming is still the principal source of removal of trees from forests.
Do you see any willingness on the part of private corporations or industries worldwide to do the kind of full cost accounting analysis that you suggest needs to be done in order to fully calculate the impacts of the activities we now carry on?
Not so far, but I did receive an invitation to visit the World Bank in Washington next week after next. So maybe it'll be interesting to see from them if there is any such move.
From reading some of your writings, etc., I understand that the organisms and the climate, the Earth function keeps the quality of life and everything in order for life to survive, kind of on a subconscious level. They just do it. Do you think, since humans have such a major impact on the Earth, they will do it on a conscious level with as much importance as plants and animals will?
I didn't quite understand that. Are you asking me, do I think that the fact that humans are conscious has a special place in the system? Yeah. It's something that I try to avoid thinking about because it's very much more difficult. I know that the system has run for 3.5 billion years quite well before humans appeared. And I think it's first important to establish how it did that before moving on to the much more tricky thing of what are we to it. And one should always remember that for the first billion years that the Earth existed, it was run entirely by bacteria. There was nothing else on it.
One of the problems that confronts us in getting any sort of change going on in what we're doing today is that the problem often seems so large or is presented in such a way that it's only like the industries that can make these changes or the governments that can make these changes. And so we find ourselves watching Captain Planet and the Planeteers fighting evil polluters, and there's very little that is presented to us that the normal people and the rest of the world, what are the things that we can do to change in our personal lives?
Oh, I think one should never be pessimistic. The last few years have given great cause for optimism. there's changing government in Brazil, for example. It may not be sustained. I don't know anything about the politics there, but I do know that they now have a president and an environment minister who are dedicated to the stopping of the clearing of the forests. And they're using the Brazilian army to achieve this result, and I understand with some success. And I also hear that similar things are beginning to happen in Colombia. So, and this is quite sudden. And one should also look at the enormous changes that took place in Eastern Europe and Russia just over the last couple of years. And to a large extent, I think, when they are fully understood, it will be found that the great political upheaval in the East was driven by desperate environmental degradation in those regions. So I think there is cause for optimism here. I think we are a responsive species. Our trouble is that we're cliffhangers. We like to go right up to the edge before we do anything about it. Also, of course, I think personally, I always take comfort from the thought that you only have to plant about 10 trees, I think it is, to completely absorb all of the carbon dioxide you produce by breathing, by driving your car, and by home heating during your lifetime. And this isn't an awful lot, and it will give you a great deal of smug satisfaction if you plant those 10 trees.
One last question. Can you tell us what kind of environmentalist, unusual or usual or non-environmentalist, Mrs. Thatcher was, in your observation? What kind of environmentalism does her successor, Mr. Major, represent?
Well, I can answer about Mrs. Thatcher because I did know her and have spoken to her on environmental matters, and I would say that as far as I can see, she is quite genuinely interested in environmental matters. She certainly has read my books, which would make me slightly prejudiced, of course, in this affair. But from talking with her, she had read them and understood them. And you will remember she did speak before the United Nations, I think it was a year or 2 years ago, and the whole of her speech was environmental. And she actually sent a copy of it to me for checking before she gave it. So I think she is very genuine in her feeling that to put it in her words, the 90s would see the environment usurp the political agenda. And I think this is true, and I think she felt that. About her predecessor, I don't know. I've not met him. I can't really say.
One more and then...
Okay, you say that in your basic theory that the Earth is not fragile, but we've spent a fair amount of time on the deforestation and also the certification of areas in South America and in Africa. And I was wondering, is there any indication that the Earth has somehow tried to counter the effects of the deforestation? Or was that the idea that the algae, I didn't quite understand that.
I think the important point there is that, don't forget, 70% of the Earth's surface is ocean, and an awful lot of the action goes on in the ocean, perhaps considerably more than half of it. And we've done nothing so far that even appreciably affects the oceans. So that's one of the reasons for feeling confident that the system can look after itself. It would be very interesting to discover if there is any counteraction to anything we've done, but I don't think there are enough observations yet around from which to draw any such conclusions.
Maybe we call it here and invite you all to join Dr. Lovelock in the reception in the Big 8 room just down the hall and around. What you want.